Hello there. Let's talk about converting decimal to hexadecimal. Hopefully you've watched my other videos by now, but basically we have different number systems, number bases that we can use. We have decimal, which is a base 10. We have binary, which is base 2, and we have hexadecimal, which is base 10, or sorry, base 16. We can basically convert back and forth between all of these systems. We can represent the exact same number just in different ways. Just as a quick refresher, decimal, we can have characters that are 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 total characters. That's why it's base 10. In binary, we have, just the characters 0 and 1. And in hexadecimal, it's meant to compact the representation a little bit. It has more characters or more possible characters per digit than decimal. So the number is going to be a little bit shorter usually, unless it's like very, very small, than decimal. And it'll be a lot shorter than the same number in binary. So in hexadecimal, we start off with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to get the remaining digits, we just go A, B, C, D, E, F. So we have this many characters. It's 16 total characters. We can represent a number between 0 and 15. So that's a difference between, hexadecimal and decimal. Now let's learn how to actually convert. So I'm going to start off with a number. I'm just going to type like a random number here. Hopefully this doesn't go on for too long, the conversion. So I'm going to say this decimal number is just that. How do we convert? If you watch my other videos, it's basically the same thing as converting from decimal to binary, except instead of dividing by 2 because binary is base 2, we'll divide by 16 because hex is base 16. So I'm going to start off by saying, let's take the original number and we'll divide it by, not 2, 16. What does that equal? There's no way I'm doing this in my head. So I'm just going to use a calculator for every single step. I'm not even going to try. I'm going to say this number divided by 16 is 511757 with some sort of a remainder. So I'm going to go 511757 remainder something. So in most calculators, you can just punch up the modulo operator, which is like the percent symbol. Before I do that, I just want to point out 0.75 is 3/4 of whatever it is that is one, that one character can represent. We know we can represent 16 different values. What's 16 divided by 4? That's 4. So 3 of those should be like 12, I hope, unless I'm saying something totally wrong. So I'm going to do modulo, so that's 12. Okay, remainder 12. My dog is growling at me. Pause the video. He likes to lie about peeing. He doesn't actually pee. He already did a huge pee, and then 3 times after that at 20-minute intervals, he went out there and lifted his leg, and just like 3 squirts came out. And he expected a giant treat for it. I'm not doing it. You're not getting that treat. I expect a big pee-pee if you want a treat. You dog? You dang little dog. Okay. So here we are still dividing. I got the remainder. So then we just need to take, the quotient result. What is the result of actually dividing? Just carry it over to the next line. I'm going to do some spaces to make it look all even and continue to divide. So divided by 16 equals something. Don't forget that if you have the modulo operator over there, you got to take it out. Go back to division. It's going to be 31984 remainder something. I'm going to move that over. And what's the remainder? I'm just going to get the modulo. I don't want to recall what 0.8125 is. I'm sure some of you out there can already do that, but it is 13, remainder 13. So I'm going to go 319 divided by 16. 31984 divided by 16, so it's going to be 1999. Okay, so carry that over real fast though. Divided by 16 equals 1999, remainder something. There's no decimal point at the end of that, so I can just assume the remainder is going to be 0. If you want to double check to be sure, which is a good idea, use the modulo operator. If your calculator doesn't have modulo, find another calculator or jump into Python or something. So I'm going to carry over 199 to the next line there, divided by 16. is something, 1999 divided by 16, it's 124 point something. So 124 remainder, whatever modulo says, 15. That's pretty cool. All right, then I'm going to carry it over, just 124 divided by 16 again. If you were hoping I'd be able to do it in my head by now, you were wrong. 124 divided by 16, it's going to be 7.75, so just like 7, remainder something. What did I say last time for the 3/4? Was that 12? Whoops, I can't remember anymore. 12, yeah, okay, so remainder 12. And then we'll carry it over and we'll say 7 divided by 16. So we know that, 16 doesn't really fit into 7 at all. So it's going to be 0 remainder, whatever the number is. Let's punch it here just to double check. We'll say 7 divided by 16. You can see that it's 0. And then the remainder is going to be 7, just, what the original number was. So now at this point, when the actual, carry down quotient is going to be 0, then we just have 0 divided by 16 equals just 0 remainder 0. And it'll just continue like this forever and ever and ever and ever and ever. So this is how you know you're done. Another thing that I mentioned in other videos is, how do we actually know where the zeros belong? I mean, if you read this intuitively from the top to the bottom, you might think that, the top number is going to be like the first digit, but it's actually backwards. It goes from the bottom up. The reason you can know that is, again, based on my other videos, if we just type a random decimal number here, if I add zeros to the right side, I'm actually changing the value of the number. I'm making it bigger. But if I add zeros to the left side, I'm not changing the value at all. So that means those zeros here, which could go on for infinity based on how much tenacity you have, they should be on the left side, because you don't want any amount of these zeros to change the value of your number, because it's an arbitrary number of zeros based on how fast you get tired of doing zeros. So that means if I go from top to bottom, I have to reverse it. If I go from bottom to top, it's already going to be in the right order. Or sorry, if I correlate, or if I map bottom to top to mean left to right, then it's fine already. If I map top to bottom for left to right, then I'll have to reverse it when I'm done. So I'll do it both ways just to show you. But there's one more step we need to do, because in hexadecimal we have more characters than decimal. We have to translate what does this 12 and 13 and these other numbers mean. Luckily we had some of them in there. It could have been too easy. So remember, in hex we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have A, B, C, D, E, right? So we know that the value of 0 is 0, and 1 is 1, and 2 and 2, and so forth, right? Like 9 is 9. But what's the value of A? For each increasing digit, the value just goes up by 1. So that means that A is worth 10. I'm going to write this vertically just so that you understand that this means the strength of the A is 10. And then the strength of the B is going to be 11, because it just increases by 1. The strength of the C is 12. The strength of the D is 13. Oops, I forgot the F. Hit F in the chat if you forgot the F too. So the strength of the E is 14. The strength of the F is 15. And then we're done. And remember, there's 16 digits total. So the highest value is 15, because it includes the 0. So, 16 total possible values you could represent, but the highest value, 15. So that means every time we see a 12 here, we should actually say that that's really a C. And every time we see, actually, let me put the other C in there real fast. Every time we see a 13, that means it's a D. Every time we see a 0, 0 through 9, it means the original number. Oh wow, we only had 2 digits that are going to mean the original number. So mark my words, the 15 is going to be an F. Every time you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it maps to the same number. So 7 maps to 7. It's totally fine. The only time it maps to a letter is, of course, when you exceed 9. So 10 and above are going to map to letters. So now I have these mappings. I just need to sort of scan my work to come up with the correct hexadecimal number. So I'll start from top to bottom, because it's a little bit harder that way and it'll be more brain practice. I'm going to go C, D, 0, F, C, 7, and then, as many zeros as you decided to calculate. And hopefully this reminds you, oh no, I'm increasing the value by adding the zeros. That means I have to reverse everything. So I'm going to get rid of these zeros though, and I'm going to reverse it. 7C-F0DC. Okay, great. Now let's double check, because it's always a great idea to check your work in different ways with different methods to decrease the possibility that you're accidentally wrong. So now I'm going to go from bottom to top and see if it's the same thing. 7C-F0DC. Does it match? Yes. So now I'm pretty confident that I have the right answer. Let me punch this up in my personal calculator real fast. I'm going to do, just to double check the work before we cut the camera, because if I'm wrong, I want to be able to correct myself right away instead of coming back with another video later, which sometimes I guess I'll have to do. It's saying that 7C-F0DC is the correct answer. All right, so we now have converted our first number from decimal to hexadecimal. Nice. And by the way, if you didn't already know this, you're supposed to put a prefix in front of hexadecimal numbers, not necessarily in every program that asks for hex input. Some of them are not programmed that way, but in general, when you expect someone to read your numbers, if it's hex, you want to put OX in front of it, because you don't want them to confuse. Let's say we have this number and this number and this number. All three of those could be a different number depending on whether they're binary or decimal or hex. But if you put the symbols in front, this is binary, this is hex, then now the reader knows that these are three different numbers, and they can infer what the numbers mean. Okay, so let's just do like another number. We'll make it a little bit smaller so it's easier. We'll say decimal, and we'll go 223. So it's faster. So we start off with 223, we divide it by 16, and that's going to be something. So 223 divided by 16 is going to be 13 remainder something. I'm going to do the modulo operator. And by the way, if you don't have a modulo operator and you can't figure out a better way to do this, a good trick is to just say, let's take 13, because that was the answer, right? 13 point something. We'll take 13 and multiply that by 16 again, so it goes higher. Then take the difference between that and the original number. So we can say 223 minus the number multiplied back up, and it'll tell us that our remainder is 15. Let's see, was that actually the remainder? Let me just double check here. Oh gosh, what am I doing? 223 modulo 16, 15. Yeah, there it is. If you're lazy like me, you could also do something like this. I tend to do this when I don't have a modulo. I'll do 13 times 16, and it's 208, and then I'll just subtract the original number, and then we get negative 15, but then I know it's not negative. I know it's 15. So it's just like it makes you a little bit faster in the calculator. So this number I think was too small, because we just do 13 and then divide that by 16. Obviously the answer is going to be 0, remainder 13, and we just have a 2-digit hexadecimal number. Let's do that real fast. What is 15 going to be? It's A, and no, not A. Sorry, that's F. Subtract 2 from that, D, E, F, so it's going to be D, I think. So then if we go from bottom to top, it's going to be O, X, D, F. Let me double check that I'm telling you the right thing. 223, D, F. Okay, so we got it right. Let's do something just like a little bit more difficult, but not as difficult as the first one. So I'll try 4 digits maybe. How about that? 4 digital digits. How about that? We'll do 2816 divided by 13 equals something. 2816 divided by 16, that's 176. Remainder something. There's no decimal point, so I can just assume that the remainder is 0. Nice. 176 divided by 16 is 176 divided by 16 is 11. Another 0 remainder. Getting kind of boring though, isn't it? Remainder 0. And then we'll do 11 divided by 16. That's going to be 0, remainder 11. That's too easy. Okay, so what is 0? 0 is 0. You're welcome. And then what is 0? It's also 0. And then what is 11? That's B. So we should have a number now of 0xb00 if we're going from the bottom to the top. If you go from the top to the bottom, of course, it'll be 00b, and then you reverse it, b00, but I just wanted to skip that step for now. Let me punch this up into my personal calculator to make sure I don't need to make a correction. b00, there we go. Also, here's another thing to keep in mind. Most of the time when we use hex, it's to read, sets of bytes. which typically go in patterns of 1 byte or 2 bytes or 4 bytes or 8 bytes or whatever. So the cool thing about hex is one character can represent a number from 0 to 15 or 16 combinations. And if you think about that in binary, that's 4 bits, right? It's like 1, 2, 3, 4, 1, 2, 4, 8. Multiply 8 by 2, that's 16, subtract 1 is 15. So you can go from 0 to 15. So that means for every character in hex, you get 4 characters of binary. So it's like a huge savings, right? But the point is, if you wanted to represent 1 byte, that's not going to be 4 bits. That's going to be, 4 bits followed by 4 bits, so for a total of 8 bits. Even if there are zeros in the beginning, in binary, if you're representing a byte, you typically want to pad the zeros to the left so that it looks like it's aligned to nice blocks of 8 or 16 or 32 or 64 in terms of bits. So we should do the same thing with hex. We should always have 2 hex digits together. We should try not to have like an odd number of hex digits. And if you want to get more strict than that and say like, oh, only 2 or 4 or 8, you can do that. But I just will say, pad it with a 0 to the left. Remember, when you pad a number with zeros to the left, it doesn't change the value. Like if I just put a bunch of zeros in front of this decimal number, it wouldn't change the value. So we can do that with hex, and it looks nicer and neater, and people can quickly see, okay, so there's like a byte right there, it's OB. They can imagine, oh, that byte is probably 11. So there's like an 11 byte, it's like got a sequence of zeros and ones, and then there's another byte right after it, which is smaller, which just has zeros. So it just helps the reader visualize what's going on. Okay, I'm going to cut the video here. I hope you enjoyed this video. I hope you learned a little bit of stuff and had a little bit of fun. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.